Welcome everyone. So this is Hive and Druid Bird of Feather sessions. So it's supposed to be a user discussion format, basically. So I mean, we have bombarded you with presentations over the last 2 days. And this is supposed to be the other way around, that you guys get to ask questions. So that's the idea. I mean, if you have any questions, please bring them, and then we can discuss. We have a lot of people from the dev community and also users here as well. So its idea is to basically learn from the shared experiences. So just to kickstart the discussion, I have like a couple of slides which talks about new features in Hive. Some of you might have seen that yesterday. I'm just gonna go over them quickly. So the major items which are there in 3.0 are workload management, materialized views, asset improvements. So you might also have attended the talks targeted individually on these topics. So those are the big items. So workload management is basically for improving the resource utilization and the guardrails for the proper utilization of the cluster to allow even more concurrency in the LLAP cluster. Materialized views for performance. If you have repeated workloads and you know your query patterns, and if these queries are changing but not drastically, this feature is pretty useful. And then the asset V2 on the storage side, we have made quite a bit improvements on the storage format to make it more performant. And in fact, now it's possible to use it as a default mode. All your tables, and then now you can create as asset tables. There are configurations which lets you choose that in a default setting, so that user doesn't have to qualify their tables with any other qualifiers. So the major change was there that the updates are now modeled as inserts plus delete. So the merge during the read is much faster. That has got a lot of speed up, and also we have made it work with a lot of other Hive syntax. So they can be used, asset tables can be used in almost, not almost, in fact, all of the Hive syntax. So those were the big items. There were other improvements as well. Query reoptimization, which lets us to now change the query plan while it's executing. So we can intercept if there is a failure and then use the statistics for the vertices which have been executed, and then use those statistics to generate a new plan and execute it. So that's in query optimization. Vectorization has seen a lot of improvements. There are new operators like window functions which are now vectorized. There are new expressions like case statements which are now vectorized. There are new types which we have extended support for, like timestamp and so on. So there are a lot of improvements there. Constraints to help with the data integrity. Now you can define constraints like default clauses or not null constraints. They are primarily used for ensuring that your data integrity is maintained, to reject the bad data from getting into the tables where you know what you expect. But they're also useful for optimizations. Using this, optimizers can take certain decisions which will help go query fast. So the result set cache, we now store the result set from queries on HDFS, and if we see that same query again, we can answer that directly from the cache. And this actually also avoids the planning and optimization phases and so on. We intercept it pretty early. So that's pretty useful. It's used particularly in the BI kind of workload where a lot of different analysts are interacting with Tableau like a system, and then usually the first few queries are similar where they do a count star on those tables or group by on a common dimension. Hive Server 2 for LLAP now gets HA. That wasn't the case in Hive 2. This is right now active passive, so there is another Hive server 2 which is waiting for to take over if in case there is a failure on the first one. The cache store is basically for meta store, and all the metadata can now be cached in the meta store daemon, and which avoids the RDBMS round trip. So, especially in if you have large metadata, which happens when you have large number of partitions or table objects, this particularly comes in handy. We have HLL bit vector improvements, which lets the planner to do better planning by making good estimate on the NDV of the tables involved in the join. And there are numerous other enhancements in Spark integration, which I haven't kept up with, but there are also there. So if someone has any questions or clarifications on these new features or any other items, we can discuss them now. Else I will I'll ask Nishant to go over the Druid stuff, and then we can maybe do it together.
Yeah, sure. Thanks, Ashutosh, for going over the Hive stuff. I'll just quickly take like 4 or 5 minutes to go over the updates on Druid. So we have been in Apache incubation. So we recently moved to Apache incubation in February, and we are still figuring out the migration logistics. We have migrated the dev list and are in process of migrating the source code base and the user list. So if you are interested in learning more about Druid or have questions, do use the new mailing list, which we have the Apache mailing list. We'll move the website soon. And we also did a 0.12.1 release recently, but that is not an Apache release. Also, we are planning to do 0.13 later on when we move to Apache. So hopefully 0.13 will be our first Apache release. Talking about the features in 0.12.1, so we have done multiple improvements. This Kafka indexing service was what we introduced in 0.10 as an experimental feature, which supports exactly once ingestion from Kafka. So there were some limitations there that it could end up creating many small segments, which will be suboptimal for your query performance. So we have sort of earlier it was the number of partitions and the number of segments being generated was linked together. So we have delinked them, so now you can have one segment for multiple partitions, and also added support for incremental publishing. So without waiting for complete R, you can incrementally publish if the data load is being high, which is coming in based on some certain number of rows. The other big feature that is added in Druid is automatic improved segment management. So if you get into a situation where you have many small segments, we have added a compaction task, and the Druid coordinator can automatically look at those smaller segments and compact them into bigger segments. So that helps a lot with the query performance improvements there. For the parsers that parse the queries and ingest into Druid, we have added support for batch parsing there. So rather than doing each event one by one, you can write your custom parsers that parses complete batches. A numeric quantile sketch aggregator was added, and basic authentication and authorization mechanism was also added in this release. So you can this basic authentication and authorization just supports basic auth there, but you can extend that, and since it's pluggable, you can write your own custom extensions to extend this feature. So we have provided proper hooks in the Druid platform for authentication and authorization. There are some improvements in the query request queuing. So on the broker side, there was an issue that if you end up sending a lot of queries, and those queries are taking a lot of time, and if the client even cancels those queries, they will still be processed on the Druid broker side. So we have done some improvements, and there are many other performance improvements to group by other query types. So if you want to know more about this release, that is the link to the release notes. On the Druid and Apache side, we have tightened the integration even further. We now can recognize more functions and push like expressions from Hive side to Druid. Also, we have worked on like closing the gap between the two systems. For example, like time zone handling, how like these two systems handle time zone differently. So we have closed that gap. And for like handling of null values, Druid used to treat them as like zeros, but we have worked on that, and like the semantics are like same for Druid as like Hive has. The other big feature is like materialized views. So if you have tables in like Hive which are for star schema or anything like that, you can just like materialize them in a denormalized form into Druid and run your queries over those like materialized views. And there is like support for automatic query rewriting. So your queries, you need not rewrite your queries. They will be like automatically rewritten if there is a materialized view present for that can be used to serve your query. So I think that was pretty much it on like Druid and like Hive side together. So I think we can open up for like questions, discussions on like different features, and just go over them. And if you also like, if any of you wants to like share any use case or any experiences that you had with like Druid or Hive, please do that.
Yeah, and it's not only about new features. I mean, if there are some issues that you are struggling with the existing releases of Hive 2 or Druid 9 or 10, this now is a good time to bring them up, and we may find some solution over here. Yeah. Sorry, repeat the question. So the question is, when you create a table, do you refer to them as internal table or external table? Oh, which prefer? Oh, I see. I mean, I don't know. Anyone else wants to take a stab at first? Or, I mean, I can answer that, but okay. Yeah, so we certainly prefer the managed tables. Yeah, because then Hive can make more assumptions about how the data is laid out and can do extra optimizations, right? Because in case of external tables, the way people use it typically is that they drop the files in the directory of the table in the HDFS and then expect that to work. So that is good. But for example, in case of ACID, that cannot happen, right? We cannot keep track of the statistics for that data which is not coming via Hive interfaces. So we cannot apply many optimizations which uses statistics on them. And then the life cycle of the data itself is outside of Hive. So there is nothing, no guarantees which you can expect from Hive either, right? So because of these different reasons, we prefer the managed internal tables and not the external tables. Yeah, I mean, if there is really so one use case where people do want to use external tables is that when the data is generated outside of Hive and they want it to be now queryable via Hive, right? So for that, we suggest people to use actually a load statement. For example, you might be generating a Parquet data from some upstream process which is now in the HDFS. So instead of just moving the files, you can use the load statement, and that will notify Hive that new data is coming in. And with 3.0, the load statement is also supports ACID tables. So you can actually load into the ACID tables as well. And that is the workflow we recommend people to use in case data cannot be ingested directly into Hive, to use the load statement, which is a pretty cheap metadata operation. Yeah.
Can you specify details on Spark-specific enhancements?
Okay.
Is there a Jira ticket or anything that I can look at?
Sure. Yeah, so the question is on the Spark related enhancements in 3.0 or before. Yeah, I mean, I can answer that. I was looking for Eric or someone. Okay. Or Gopal, you know. Some more participation.
Yeah, so we have a we have a Hive warehouse connector that lets you, from Spark, read Hive data directly. You can read transactional data. You can read any format that Hive supports. So it's a higher level interface that kind of abstracts away everything that Hive might be doing internally, and therefore lets you, use internal tables, use managed tables, use asset tables, use statistics, and do all of that stuff. And then process the data ultimately in Spark. So you get to choose how much you want to push into this connector. So any query you can push into, you can say, I want to join these 3 tables and then load into Spark. You can say, I want to read the raw data and then do the join in Spark. So that's all up to you. You can handle this however you want. We've integrated it with Apache Arrow. So we use Arrow on the wire to transmit the data as quickly as possible between LLAP and Spark. I mean, it kind of gives you the best of 2 worlds. You can do whatever power Spark brings to the table, and you can first prepare the data in Hive before you read it out. And we did our best to make the performance, as fast as possible to transfer data between these 2 things. We've added additional things. So you can also go the other way. You can write into Hive. You can stream data from Spark streaming into Hive. So it's a pretty complete interface that lets you make Hive and Spark work together in your application and your workload. Another advantage is security, right? You can define security features in Hive, and since you're reading through Hive, the user that is accessing the data and is running this job will enforce the column level, row level security before they read the data, which is kind of a neat thing. So that's in a nutshell. So we are rolling this out in Hortonworks in HTTP 3.0, and it's a GA, so you can use it in production in that release.
There's a question here also. Yeah.
Is there a way to, you have suggested to optimize left arrow joins? Let's say I have a table and I have 20 other, insert as select statement, and I have 20. Thank you. I have 20 lookup tables. I'm just looking for 1 record in there, and my main table has a couple million records, and I just want to optimize that. Is there any suggestions you want to do?
Okay. So let me just repeat the question so that everyone gets it. So I guess the question is that there's a left outer join wherein on the left side, there's a large table, and then you are doing a join on the outer side with 20 different tables. And you expect like the result set to be pretty small. And then is there a way to optimize that? That's the question, is it? Right?
The main table, it's selecting all the records, but I want to do lookup on 20 other tables that each has a record in it.
Okay.
And that's a typical scenario.
Yeah, so we have our performance experts here, so let's hear from them.
So I kind of want to ask, so are you using this today, and like, are you seeing performance issues with Taze, or like, how are you using this today? Okay, and are you on HTTP, or are you using Taze outside of HTTP? Is it like, are you using Hive to?
From Apache, or?
Yes.
Okay, so we had some issues with chained left outer joins on the same key in Hive a while back, where we disabled map joins for these small lookup tables entirely. We fixed it in HTTP 2.6.5 and Hive 2, where we no longer merge those joins so that we can actually run them as map joins one after the other. So the problem that you have is that even though there's only 1 row on the outer side, it's probably doing a big shuffle join. That's fixed. But if you're doing the other way around, if you're like, say, you have like a transaction database and you want to look up one transaction in a giant database, but you want to join against all your customer demographics, all those tables, we now have a second set of optimizations where we will take the transaction table, filter it, produce the one row, and use that one transaction ID row, grab the user ID out of it, filter the user table using it before you load it into the memory. Filter from the user table shuffle, we'll take the demographic for that user, filter the demographics table out of it. So what eventually ends up in memory is going to be for the transaction that you looked up, the user that you're looking for. We will not move any of these data items over the network anymore. And that's the semi-join reduction patch which came in Hive 2. So that also helps left outer joins. But it only helps left outer joins if the outer side is large. Like if your customer table has 20 rows, it doesn't help you so much. If your customer table has 200,000 rows, then yeah, this helps you a lot. So if you think of a telco call, two people making a call, you want to find out who those two people are in an address book, and your address book is giant. That's the kind of use case where left outer joins help, because you're not sure this person belongs to the same telco, but you want to look it up if they are. And you'll say calls, join customer again. And that kind of query pattern we have improved recently. So I don't know which one of those two fall in, but both we have worked on.
I think the first point about enabling the map join for left outer join with the left side is bigger will help you the most. So that I think is fixed in the later versions of Hive. Yeah.
Thank you.
My question might be a bit generic. So whenever we submit a Hive job, it compiles and then submit to Yarn, right? So you can find the log from Yarn from Hadoop, right? But sometimes that and is there a way to, and also there's a Hive job, right? Is there a way to look at the Hive jobs log?
Okay, so I think, let me repeat the question. So the question is that when you submit a Hive, so I'm assuming you're not using LLAP, of course. You are submitting a Hive query which submits a Tez job, and then the logs for that Tez job you want to get to.
Right.
And then, so there is no Hive job. I mean, there is extra logs in the Hive server 2 for that. And so that's something you may look at. But when the runtime and with the Tez, there is only a Tez job which is running, right? So for that, if you have a Tez UI, for example, or so you need to know the application ID basically of the job which is submitted, which is also printed on the console, and then there's a yarn command through which you can get all the logs for the particular job. So that's the one way to get the logs. The other way, for the Hive server 2, it basically writes its logs into a specified log file. And it has a query ID, actually, through which it can make association of the logs related to your particular query. So this is what the current state of the art is. I don't know if you use HTTP, but there are more Tez views and Hive views which we are getting revamped in the next release with DAS. So maybe Tejas or someone can tell us what improvements can come, users can expect with respect to logs in that new setup.
So hello. So we have implemented a better way to kind of even see the progress of your job on Beeline, wherein it will now show like if your query has multiple mappers and reducers, then it will show even on Beeline, very a proper query progress log, and you don't need a UI per se for it. We also have another.
The Tez, viewing the Tez. Okay. All right. So we have a new, as part of HTTP 3. So we have something called Data Analytics Studio, And in that, you can see the Thais graphs properly and like how much time was spent in each stage of the Thais DAG. And apart from that, there's links to download the like logs for that Thais application. So you don't have to go and run a yarn command. You can just click on a link to download the logs.
So the question basically goes back to, is yarn as the only way to look at the logs?
Is the yarn the only way to look at the logs?
The only log that you can look at.
Yeah, so I think, so let me ask you another question then. What's the reason you're looking at the logs? Is it the performance, or is it that you want to know what operations are happening in the query? Like, what's your motivation to look at the logs?
When I'm running jobs, I notice that sometimes like it's a job that like has a Hive ID, right? Has a Hive job ID.
Mm-hmm.
And also has a like sometimes it doesn't even go to the point that it has an application ID. It sometimes it's got stuck before it's even got submitted to Yarn.
Okay.
So I want to know what happened in the between. So
I
that's
see.
why I wanted to look at the Hive job
I see.
logs. But I never
So how are you submitting these queries? Are you submitting through Beeline, or are you through some other tools, or?
usually Beeline.
Through Beeline, I see. So yeah, so the question is, sometimes you don't even get the application ID, and it's still compiling the query and it's still stuck. So yeah, so then this is basically right now in the Hive Server 2 process where the compilation is happening. So I will then suggest you to use, if you only have access to the logs and not the DAS and new things which are coming up, then we have something called perflogger, which logs how long each stage of the compilation is taking. And then using that, you may correlate what's happening in the query at that point. So all of this is going to be much better in this DAS world, where you can visualize all this information, like how long the compilation took, how long the submission of the job to the LLAP took or to the yarn took.
Yeah, and the query-specific logs would be printed on Beeline. So the like what stage it is in, if it's a parsing stage, and if it has run, and the application ID if it has run. Those things would get printed on Beeline in the recent versions of Hive.
Yeah. Which version you are using?
Which version?
Yeah, which versions of Hive or HTTP are you using?
Point something? I don't know. I don't do a deployment.
Okay.
Yeah, I mean,
All
so
right.
2.6 is the two-line, the most recent version. So I mean, and even like 2.5, 2.4, they should also have the logs printed on.
Who are the latest?
Yeah, you should
Okay.
encourage your operator to upgrade you to the latest version of Hive. Latest and greatest. Yeah. Question there. Oh.
Hello. All right. So we see quite a few vendors, third-party software that's injecting the caching layer between the BI tools and Hive. With version 3, I noticed you had a caching layer there.
Mm-hmm.
Do you see long-term a need to continue to have third-party caching layers, or do we want to get all that functionality into Hive and connect BI directly to Hive long-term?
Yeah. Okay. So which caching layer? Is it like at scale or in Tableau is the cache? Where is this cache?
Yeah, not Tableau cache, the third party. So yeah, like at scale, and there's a whole a list of them now. You see the.
I see. Yeah.
The.
Yeah. So it does get better in Hive 3.0 for sure. I mean, now we have the data cache in the LLAP, which improves the performance. We also have the result set cache in even before the query hits the runtime. So these things should certainly help and eliminate the need for the caching. The other thing you can look at is that people typically use at scale to define their cubes because they know their query patterns and what are the typical dimension and matrices their users are going to look at from Tableau and to help speed those queries up. So that story can now be better served with the materialized views. Instead of defining cubes, you can so cubes are more richer, but in many cases you can define a materialized view which can help you speed up those queries. Because at the end of the day, these at scale or those tools, they still present themselves as a SQL source, right? So the Tableau still speaks SQL to them, right? So they are not actually, even though you are defining the cubes, you are not, Tableau is not making use of it. It's not aware of them, right? So in many those such cases, the materialized views comes handy because you can materialize them and then for the future queries, those will be much faster once you have that. And of course, we have now the result set cache and the LLAP cache, which is much more efficient, which is going to help your query if it actually going to get to execute them.
So I kind of wanted to say that the biggest problem with using a third-party cache is that it has to find out that the data changed from the backend somehow. The best part about integrating like the result set cache or the LLAP cache is that it's consistent. It will not give you a best effort answer ever. It will either give you a correct answer or it will actually fall back to executing whatever the whole thing it wants to execute. So you never have to worry about those 1 or 2 minutes when somebody's changed data, your dashboards are not refreshing or things like that, which affects systems which are external to the transaction system we live in. So as people start to load data every 5 seconds or 10 seconds, the utility of an external cache will slowly come down.
This question is for Druid. Can Druid support like 50 columns of table, but still with high performance during ingestion?
Yeah, it can support. Like I have seen use cases where like people are loading like 100+ columns, and they are getting like good performance. The main thing is like it's a columnar, so any queries like that, like to answer a specific query, it only scans the columns which it needs to scan. Right, so it doesn't look at like all the 50 columns. If you have queries that are accessing only 5 columns, it will just look at those 5 columns.
But during ingestion, can it handle like millions of rows?
Yeah, I have seen that. Yeah. I mean, I have seen like a couple of hundreds. So yeah, 50, 60 should be like good enough.
Okay, so millions per second, it's fine.
I think so. Yeah, that should work.
All right, thank you.
Thank you.
Is that a promise?
I said that should work.
Thank you. Do you have any, I guess, tips or guidance regarding resource management in a multi-tenant cluster when you're dealing with Hive, which is if you're either using LLAP or if you just turned off impersonation? Just in general. Everything's running as Hive. Now, how in the world do we manage resources when there's a million different groups coming at us?
I think the first part is that we don't, even if a query is impersonated, we tell Yarn which user it is, right?
So yeah, actually.
Two-part answer. First, thank you very much. What else would be?
Can you just tell me what to say? Is this on? Yeah, I think it's on. So first of all, yeah. So we have a little bit. We have a feature coming up in Hive. Apache Hive 3.1, I think, and in HDP 3.0, which is called Workload Management. It is mostly targeted, like on 90% targeted on LLAP use case, and it basically allows you to specify policies kind of configuration to divvy up the cluster between different users. So while everything is running inside the cluster, everything is running as Hive. On the Hive server 2 level, the cluster is separated into, like there's like management of resources between users and like restrictions and priorities and stuff like that. I think there was more about it in some talks, so the slides might be published. I don't know,
I'm trying to pull up that slide, yeah.
Yeah, so for TES in particular, we have kind of like a separate fix that basically allows us to, so basically you can specify the restrictions on yarn queues based on the users, basically set queue ACLs on yarn. And even though the query itself will be running as a Hive user, Hive will actually do a check first as the user submitting the query against yarn to see if the user has access to the queue. So that is something that's coming, I think, in 3.0 also. Yeah, so Hive will, like, if user Joe submits a query and Hive will ask yarn, does Joe have access to this queue? And if yes, it will start the query as user Hive. If no, it will not start the query, but yeah.
That's something new in 3.
Yeah, that's also new in 3.
Yeah, so this is the example where you can create a resource plan.
Yeah, that's my slide.
Yes, it's yours.
Yeah, so this is an example for LLAP where you can create, like, for example, it's a simple example that we give to as kind of the basic example. You create resource plan and separate the cluster into BI and ETL pools, which is kind of like the pool is basically the pool of resources, and you give 75% to BI, 25% to ETL, and specifies the number of concurrent queries allowed in these pools, and then this has more advanced features on the slide. Basically, you create like rules to downgrade queries that run for too long from BI to ETL pool, so they become subject to like new restrictions if they cross the threshold of runtime in this example. And by the way, this is my old slide, so the syntax actually changed since then. But that's the basic idea. But unfortunately, most of this, so for TES in particular, you can still create rules, but the only thing you can do is kill the query and some criteria, like if it takes too much data or if it's too big, if it runs for too long. For most of the things are only applicable to LLAP. Yeah.
So even though the impersonation actually happens, and you might go to the resource manager UI and see Hive user, the way the view yarn has is actually slightly different of what actual user is actually running the query. So we can actually run, the main reason people like impersonation is because they can make rules based on their admin login system and in yarn and expect it to work. That we kind of bridge over by collaborating with yarn. Like we tell yarn, hey, I am running this query on behalf of this user.
Does that mean that right now, if I turn off impersonation without Hive 3, just under the HDP 2.6, I could actually set up yarn queues with impersonation off and expect that to work?
Yes.
Okay.
No, so instead of just, earlier we would impersonate all the way through, through HDFS, through Hive, spin up, through the application launch, everything like that. Whereas now we would only impersonate our communication with yarn.
Okay.
Yeah.
That's 3.0. Okay. I'm not going to get that in 2.6. Okay. Thank you.
First off, thanks for all the great work you guys have done on Hive and Hive 2 and all that other jazz. It's really made a difference on our system. 2 questions. One's easy. Should we be using strings rather than varchars? I've heard that from somebody.
Yeah. At the moment, yes, because anything that varchar adds is just overhead. Like if you don't really need the semantics of varchar, varchar is basically saying that when you're joining a varchar 1 to a varchar 7, do some extra work.
Oh, okay.
And strings, we basically say, well, you can join a string to any string without anything else.
Okay. The other one is we are dumping data about, we're onboarding about 20 billion records or so between 300 to 400 tables. So right now we're writing that back into the back end of HDFS to where Hive lives as ORC files with all the things that are going, and we're completely not writing through Hive at all. But we're eventually compacting it so we get the file sizes back up to good size. Is there anything related to LLAP or anything else that you guys are doing that would change the way we're doing that? It's a one-time onboard, so it doesn't have to be daily or anything like that. But that's the way we've done it so far. Is there any better recommendations to do it rather than that? And
So
does that make any sense?
So you are right, like 20 billion records into HDFS, and then how do you tell Hive that this is a new?
We're writing it into as ORC files to where Hive thinks the managed table is at. Or
see.
a stage table. And then we do an insert select to just copy it from there and put it in the final tables.
I see. Yeah, so in 3.0 world, we actually recommend to modify that workflow. As I was talking earlier, that you go through the Hive interfaces to let Hive know that there's a new data coming in. So in this workflow, what I will change is basically that add a load statement to once the data has landed into HDFS, and then do a load into the Hive via the load statement. This will let you, so this will help you in multiple ways. I mean, for example, if you are using ACID data, these are the ACID tables. Using this mechanism, you can load new data coming into the ACID and ACID tables. That's one. Other is it will also notify Hive of any changes in statistics which needs to happen, so that it can update it. And also the data is actually the managed tables are actually managed by Hive. So you don't want the multiple users or processes writing into that target directory. So writing into them directory and then doing the renames via load statement make sure that the ownership stays with Hive for all that data which is coming in. So, so in this workflow, I will modify, as I said, I add a load statement so that Hive comes to know about what's new coming in.
And just to be clear, that load doesn't actually create a copy, right? You're just moving the data.
Yeah, load is a lightweight operation. It's not going to read and write your data again. Yeah. Yeah.
Yeah, thank you guys for, it seems to be the Druid is such a wonderful tool. We haven't really exposed to that. It seems to be so good that actually I can simplify my end of the problem. So let's say if we have something like maybe 1,500 columns, a table with 1,500 columns, about probably around 5 billion rows. Since Druid need the timestamp, this is time series. So how, is there any tips how I can optimize the query? Because I use that table mainly for lookups. There's nothing else but try to search some values. For example, if that table is purely just a party table, there's nothing else there but customer information.
So that does not have any timestamp?
Well, currently I don't. I can put something there. So but
you just want to do a lookup, like find a single row and do a lookup?
Yeah, but probably the search will be, I will find, let's say there's 2,000 columns. I will find probably about 10 or 15, and then use a different combination of that to search a bunch of customers.
Okay, so you just want to do a filter
Yes,
on those.
exactly.
So I don't think like, I mean, filtration would be fine. Like you'll use the bitmap indexes that Druid will create. And how often like these tables change also?
Probably on daily basis. Well, could be on half day, but not that often.
Okay. So, I mean, two things that you need to be aware about that, like whenever you do an update, if you have like the same timestamp, you have, instead of like, since the data is like partitioned by time, you have to like reindex all your data again for the updates. So that is like one thing that you might have issues with. So that's
But this is append-only data, right? I mean, are you updating the existing rows or you are just appending new data?
Insert and update.
Or both?
Yeah.
I see. Yeah, so for insert-only cases, so that they need not to reindex the data, right? This is going to be new timestamp.
For append only, you need not like reindex everything, but for like updates, you will need to do that.
Right.
And since it was a lookup, so I was expecting that there will be updates. The other thing is like you can definitely like add a dummy timestamp, but you won't get like the full benefits of the pruning that Druid does based on the segments. So all the queries that you'll fire will hit like all the segments. But yeah, I mean, the filtering would be fast as like it will just use the bitmap indexes. So yeah, one thing just need to be aware about that if you want to change anything, you will have to like reindex all the data.
Okay, thanks.
Yeah. I mean, it's timestamp partitioned data sets, right, which Druid deals with. And usually, if you have a filter on the timestamp, it can prune the segments it's going to scan. So if you do not have a timestamp, then one way that you can help Druid is that you generate a timestamp, but then you have to. It's not actually. Super artificial. Yeah, it's going to be super artificial. Yeah.
I'm just thinking if there's any way to, since it is purely artificial ingestion, so if there's any way to utilize that, so I can generate the timestamp in a way that actually help me on the.
Yeah, so the way it can help you is that if you can somehow correlate the rows with the timestamp, so and then you can use the timestamp later on when you're querying, then it will be helpful. That's not straightforward, but that's the way it will help you out. To associate the row with somehow with the timestamp, which you can later use.
I guess I would ask a different question though, which is if you're updating, why are you using Druid? Because I might think that HBase or something else would be a better option. Is that what you were going to say? Or?
Yeah, I was just going to say, does a spanner make a good hammer kind of question? Which is, yes, you can put a grip on it, but it doesn't really do the thing that... so Hive asset will do somewhat similar and HBase would somewhat similar. It really depends on how many rows you want out of the system at the same time and whether you can use the properties of those rows to group them together for HBase, or if you can't, you scan. If you're going to do a full scan, the difference between Druid and Hive asset would be just that you'll be using memory heavily for one and you'll be using disk and you'll be using less memory for the other.
Hi. It's not like a question, it's just a humble request. One of the presentation we have seen from the Walmart, they were using LLAP. And they were using 10 nodes for the LLAP, and each node has 256 GB RAM. But eventually, when they go in depth, they figured out only the memory associated with those cache was 56 GB only, because LLAP daemon was taking a lot in other processes. So due to that restriction, they were thinking they were giving the max memory to this node, but getting a very less output. So is there any plan to have some mercy on those daemons to chew up less and then provide more memory for the cache?
Actually, we are trying to do the exact opposite of what you just described. We are trying to give less memory to the cache and use more memory for the working set.
No, other way around.
Yeah, that's the direction that we are taking is to put the cache on the SSD and leave the memory to do joins. Because what people really want is joins and group bys. What they don't care is how much data is cached. People want to give as little memory as possible to the cache, keep as much so that they can do joins, rather than the other way around.
So wouldn't that defeat the purpose of having everything in the memory and do your processes?
Well, we do actually read everything into memory to do processing, but like the joins are actually done in memory. We don't do joins from, like, the cache is basically the space that we don't use to use joins. The memory that they say, the working set memory that is there elsewhere is what is used for the actual query. And we are trying to make sure that we use as much memory possible for the query and move as much of the cache to the SSDs so that we can like run even more threads in the same, even more queries in the same space. Like we are limited by the number of cores and amount of memory attached to it. And once we get to the point where we don't have any use for it, we use it for the cache. And if, like in the 100 TB benchmark that was in Neeta's talk earlier today, we didn't use any memory for the cache. We used a pure SSD cache, gave 100% of the memory to the execution engine, so that we could run like the 100 TB joins with like billions of records. So we are going the exact opposite direction. We are going in the direction where we'll start using less and less memory for the cache.
So I guess it also depends on the workload, right? I mean, if your workload is join and group by heavy, then you want to give more memory to the processing. But if, for example, if you are just doing filters projections, and if that is not that memory hungry, then giving more memory to the cache will be a better option. So, and these configurations are of course tunable. So depending on your workload, you can give more or less memory to the cache.
And is there any kind of a recommendation there, rather than every single client is figuring out by themselves, okay, this is the best way to approach it?
So yes, actually on Hornworks Community Connections, there is an article about, I don't know if we'll be able to bring it up now. There's an article about LLAP sizing, and it gives the basic sizing. And yeah, I have to actually add to Gopal's answer that in order to put all the cache on SSD, you have to have SSD. It's a very important consideration. So if you don't have SSD, you actually still, if you're running especially on the cloud, you might still want to have some memory for the cache. And we have a sizing document on Hornworks Community Connection. I think it's, if you search for LLAP sizing Hornworks Community Connection, you'll probably find it. And it gives an example of basic kind of standard sizing approach. And it also mentions briefly different considerations that you can do to, like, if you have more of this or that, you can, give more memory to execution, more memory to cache, and, depending on what your workload is.
So we have a product which is primarily based on Hive storage handlers. So just a couple questions regarding that. So the first question is that storage handlers for Hive, is it pretty much in maintenance mode, or is it being actively developed?
Which storage engine are you using? I mean, is it HBase you're using?
No, just a custom storage handler. So we wrote our own storage handler by implementing the interface.
I see. So, I mean, it's there's not a lot of work has gone into it. So there are more that can happen. So, for example, right now we do push the filters to the storage handler interface, but we do not do, like, for example, column pruning. We don't give the storage handler the list of the columns it can work with.
That was my next question. So you were reading my mind. Thanks.
Yeah. Right, so it's not in a maintenance mode. I mean, it's an open source project. We welcome contributions. It's just that it's not, I mean, no one has made any progress in that in last few releases.
I mean, there's still a bunch of additions that we've just recently made, right? Druid and JDBC, so there's a bunch of new storage handlers that are still being developed. So I think it's far from being in maintenance mode. I think it's pretty powerful and pretty popular still.
Okay, that's great. So, yeah, so like I said, my next question was going to be, so we struggled with the column pruning. So we found that it sort of works, but not quite. And then there was a very long-running support ticket on the support portal. And then eventually, I think it went into like a feature request or something. So any comments on that? So
you are from Teradata?
Yeah. Yes.
Yeah, I handled that support request.
Probably talked, yeah. Yeah, so it's a good feature. It would be a useful feature for us, but
yeah, so I mean, as I said, it's basically driven by the underlying storage systems, the need to innovate in those interfaces. So as Gunther mentioned, we are doing a lot of work with Druid, and so there are improvements being made. We haven't. So we made some changes into the interfaces as well. So now there are, for example, we have added the hooks to do the pre-insert calls now, so that we can notify the storage system to know that there is an insert coming and can reject if it cannot handle it, and so on. Similarly, there is now a JDBC storage handler, so through which you can speak any JDBC source. Actually in that work, there is, which is actually recently committed, we can push the query to the JDBC. So the query which comes to the Hive, we can, depending on the rules, we can push that query as is to the storage handler. So there can be a column pruning which can happen through that interface, right? Because we will figure out the columns needed, and the JDBC storage handler can do that. So that's something which can be used. But in case of like Teradata or those systems, they are actually don't do that in the parallel. I mean, this works for a single node system well, right? So that there's a need to like explicitly enable the column list to the handler. So that is something under. I mean, we have yeah, as you said, there is a feature request for it, and that's not something coming in 3.0. Yeah, but this is an open source project, so.
Patch is welcome.
Yeah.
Yeah.
Thank you very much. Appreciate it.
Pull requests are welcome.
I think you mentioned that if a query is kind of executed again, it will does not have to go through all the query planning and all that. It will be like cached or something, right? If a similar query is executed again, so it does not have to go through like. Yeah. Okay. Look, like, is there any like time difference between like can it be a 1 month old or 2 month old? Okay. Okay. Cool. Thanks.
Looks like no more questions. So there is one.
All right. So I recently attended the Phoenix conferences. And I've seen that we have a storage handler for HBase for Hive. So when would be a good time to use the storage handler versus using Phoenix?
I see. So your data is in HBase, and there is 2 ways to access it, either via HBase storage handler from Hive, or directly using Phoenix as is. I guess, Gopal, you want to take that question?
So the biggest difference is that the Phoenix table format is not the same as the HBase table format. So if you have data stored in HBase, in raw HBase form, Phoenix cannot read it to begin with. So you have to use Phoenix from the beginning to be able to use Phoenix in any way. So you have to basically reload all your data into Phoenix if you're in that world. The HBase storage handler is really useful for scanning through data, whereas Phoenix is really good at lookups and doing upserts. If you're using the HBase storage handler and trying to bulk read data out of HBase, you might still have a bad time because, again, HBase is not really the best friend of full scans. So I would use the HBase storage handler sparingly. And if your use case fits in Phoenix, it's probably a much better world for you. Also, Phoenix does a bunch of things like salted tables, which avoid you from making simple mistakes with HBase.
But there might be cases where you want to do some analytics in Hive, but you need an index to do some point lookups to join against some table. And so that's kind of the use case where you use Hive, but you use an HBase storage connector to kind of look up some records in HBase to kind of get that index capability into Hive. That's a typical use case. But if you're, as Gopal says, if your use case is just point lookups in HBase and nothing else, Phoenix is a good choice for that.
Yeah, and the thing I want to add is also that the compiler of Hive, of course, is much powerful than Phoenix. So if you have anything more complicated in the query, other than the point lookup, the plan generated by the Hive will also be much better. So your scans and some subsequent operations on that data will be faster. Yeah. So yeah, anything other than point lookup, the Hive storage handler will be a good fit. But if you're just doing one single row lookups, then yeah, Phoenix will be a good fit.
One more question. So back in the days, I heard a lot of conferences that ORC is the best thing since sliced bread in the query performance. Is still true? So now I'm hearing a lot of good things about Druid also. So now if I have to choose between ORC versus Druid, and then I probably particularly don't have the timestamp, maybe a huge large dimension. So in that case, shall I go ORC or Druid? And there's going to be, ORC does have a penalty of converting the data into the columnar format. Is there similar penalty on the Druid side of it, or which one is better?
Yeah.
And why?
So let me take a first stab at that. So if you are going to store your data in the org format versus the Druid, I guess I will go mostly look at the workload first. So Druid is very good at doing the fast aggregation. It's a very good fast aggregation engine where you are looking to do large aggregation on large data sets with the filters and projections. So if your workload is heavy in that regard, that you have a lot of group buys on a single tables, then Druid is going to be a good fit. And of course, if your data is partitioned and has a timestamp column, then within Druid it will be partitioned, and that will be a pretty good fit. Within that, I mean, the performance difference between the Druid and LLAP will be there some, but actually you want to look at first the cases where the Druid is a good fit, and if there is a good fit, then that will where you want to take your workload to.
How about the overhead of writing the data into ORC versus in the Druid? So which one is going to be faster, or? Okay.
So you have where is the data from to begin with?
So in my past life, I have extracted tons of data from Netezza.
I see.
And then when I converted it into ORC, it took hours, and it was a small cluster.
Mm-hmm.
So now, if I have similar use case, and now Druid is available, which route should I go?
Yeah. So for the ingestion path, should be similar time. I mean, it's not going to be super fast if you do the ingestion with the Druid, because the Druid also computes indexes when you are ingesting the data, which is similar to ORC. So if the ingestion is the main concern for the batch data, then it's pretty much a wash. I mean, you can pick either. But I guess the more important piece usually is on the read side, like how once it's ingested, because that's the penalty you pay with one time. But then the read, you are going to do a repeated queries, right? So that's where I will look at to decide on between the two.
Okay. Sorry, one more question. So on the org, there's an asset. Now, is the asset available across the board, or just still limited to org file? And in that case, if I have updates come in, so shall I stay with org, or Druid is
right.
acceptable as well?
So in 3.0, there is a new concept of insert-only tables, where we provide the transactional semantics for insert, overwrite, and insert into for all formats. That's not limited to ORC anymore. But that only supports the inserts and insert overwrite. So if you want to do the updates and deletes, then it needs to still be in org format. But if you have a Parquet data and it's only append-only use case, you can use micromanaged tables, and it will be a similar performance. And you will get transactional semantics on top of it. Yeah, insert into tables, these are called. Insert only, yeah. Yeah, sure.
So earlier today, I saw a slide that said that Hive is moving towards ANSI 2011 standard. To what extent did that happen with HTTP 3, and to what extent is it's still yet to happen?
So I'm not sure which presentation it was, but from SQL 2011, I mean, so one data point is that we can now execute all TP-CDS queries, all 103 of them. So they exercise wide variety of SQL 2011 features, including window functions, set functions, data schematic, and so on. So all of that we can do now. So that's certainly there. Is there any specific feature you are looking from the standard? Then I can probably talk about whether it's available or not.
No, not specifically. What I have a few customers that want to migrate their data warehouse data from SQL Server, from Oracle, and integrate that into Hadoop.
Right.
And they want to be able to reuse their code. So conforming to the SQL 2011.
Right. So that offload is actually the primary motivation factor for us also to implement these features. For example, the set functions that now the union, distinct, and except clauses are supported. That's primarily because people were migrating from Teradata and other systems to Hive, and they want to reuse their SQL queries as is. So we have implemented all of that. Some of it is available even in Hive 2.3, but there is a lot more in Hive 3, of course. There, yeah. So I mean, I won't say that we have implemented the SQL 2011 standard to a letter, but we have most of it is now covered.
Okay, great. Thank you.
Since you mentioned the Phoenix storage runtime handler, is that now out of GA with Hadoop 3? It was GA, I thought, or tech preview for the longest time, and 2.6 it still was.
It is currently still in tech preview, but in the 3.0 line we're looking into, there's some work that needs to happen and bring it up to speed with the latest storage handler definitions. I'm hoping that on the 3 line, maybe not at GA time, but shortly thereafter, we'll get this out.
Okay. Is it workable, usable as a tech preview? I was having various issues with it, that it just throw different errors, particularly on the column mappings and such like that, to try and get a table to work.
Well, okay, so it's not workable if it's throwing errors for you all the time. No, so there have been improvements going into it. So
well, that was 2.6 to be fair.
Yeah.
But,
so
yeah.
And on the with HTTP at least 3.0, it will still be tech preview, but we're trying to fix it up and get it out on that line, hopefully within the first 6 months or something like that. So there's some development happening on that.
Okay, that might fit our timelines. Somebody's building a website, and they're better off living in Phoenix, but I wanted to tell them that, yeah, there's a path to then join it off to Hive tables where they've got the large data sets and such. Yep. Okay, thanks.
Going once.
Going twice. Okay, thanks
right.
everybody.
Thank you guys.